Hello everyone. In this video, I'll discuss what inferred latches are, how they can get created in a design, why they are considered problematic, and how to avoid them. Let's start with the basics. In digital design, a correct combinational logic implementation means that the output depends only on the current inputs. In other words, output should never depend on any of the previous values or any stored information. However, problems can arise when an RTL code does not assign output for every possible input condition. In such situations, the synthesis tool must determine what output should be when no assignment is specified. To preserve the previous output value, the tool automatically creates a latch in the hardware, even though the designer intended to implement a combinational logic. This unintended latch is called an inferred latch because it is automatically inferred by the synthesis tool rather than intentionally designed. For the input conditions where the output is assigned, the logic behaves normally and produces the expected result. However, for the conditions where no assignment is provided, the output retains its previous value. This requirement to remember its previous value is what causes a latch to be created. Now let's look at some coding examples that create inferred latches. Inferred latches are typically created when a combinational logic block is incomplete. This happens when an output signal is not assigned a value in every possible execution path. Let's consider this example. In this code, Z is assigned a value of B when A equals to 1. But what happens when A equals to 0? Since Z is not assigned any value in that condition, the synthesis tool assumes that Z must retain its previous value. To implement this behavior in hardware, it creates a latch. A simple way to fix this problem is to assign a default value to Z before conditional statement. Inferred latches can also be created in case statements when not all possible cases are covered. For example, over here, if select takes a value that is not covered by the case statement, signal out is left unassigned. Once again, the synthesis tool creates a latch to hold the previous value of out. We can fix this problem by assigning a default value to signal out. The key idea over here is whenever an output is not defined for every possible input condition, the synthesis tool assumes that the previous value must be stored. Preserving the previous value requires memory, and that memory is implemented using latch. To summarize, inferred latches are commonly created by incomplete if else statements or incomplete case statements or missing default case in case statement. In general, any combinational logic code that does not assign outputs under all possible conditions can result into inferred latches. Now let's discuss why inferred latches are considered undesirable in designs. Inferred latches are often a warning sign that the RTL code is incomplete or contains a coding mistake. They can introduce timing issues because latches are level sensitive devices, unlike edge triggered flip flops. They may also create race conditions, making the circuit behave difficult to analyze and verify. In some situations, inferred latches can introduce unintended feedback paths where signals depend on previously stored values in ways the designer did not anticipate. This can make the design harder to debug and less predictable. For these reasons, inferred latches are generally avoided unless they are intentionally required by design. To summarize the best practices to prevent inferred latches, always use complete if else statements. Use complete case statements. Include a default case whenever appropriate. Ensure every output is assigned a value in all execution paths. Assign default values at the beginning of the combinational blocks. Use clocked always blocks when implementing registers or other intentional storage elements. Following these guidelines guarantees that the outputs are never left unassigned. This is all for this video. I hope this explanation helps you to understand inferred latches.